All right, let's talk about something that sounds incredibly complex but is, and I mean this, the secret language the universe uses to describe itself. We're diving into differential equations, the mathematical keys that can actually unlock predictions about the future. So, how on earth is that even possible?
It's a huge question, right? It feels like it's straight out of science fiction. But what if I told you the key to predicting everything, from how your coffee cools down to how populations grow, all comes down to one specific type of mathematical equation?
And that's the secret. It's all about change. If you can write down a rule that accurately describes how something is changing right now, you can build an incredibly powerful tool to forecast what it's going to look like down the road. And that is the absolute core of what we're exploring today.
Okay, so let's start with the absolute basics. What exactly are these equations, and why are they so ridiculously important?
So this slide really gets to the heart of it. Unlike a simple algebra equation where you solve for x, a differential equation is different. It links a quantity directly to its own rate of change, its derivative. It's not about finding a single number, it's about describing the rules for a whole system that's in motion.
And believe me, this is not just some abstract math theory. These equations are working all around you all the time. From the physics that governs a falling apple, to a biologist trying to model how fast a rabbit population is growing, to an investor calculating compound interest. They are the mathematical engine running underneath it all.
To really get a feel for this, we're going to zoom in on one of the most fundamental differential equations there is. And let's try to think of it not just as an equation, but as a rule of growth.
Okay, so let's use an analogy. Forget the math for a second. Just imagine you have this magic piggy bank. The cool thing about it is that the amount of money it adds each day isn't a fixed number. Nope, the new money it adds depends entirely on how much cash is already inside it. This one idea is the key to everything.
And here it is. This is the mathematical rule for our magic piggy bank. Now I know it might look a little intense, but it's saying something so simple. The rate of growth, that's the dp/dt part, is just equal to the current amount of money, p, times some constant number k. That's it. The more money you have, the faster it grows. This little equation is the rule.
Let's really pull this rule apart because this is where the magic happens. P is simple, that's just your total savings. K is your interest rate, let's say it's 10%. And then there's dp dt, the derivative. That's the engine of change. That represents the actual cash being magically added to the bank each day. The equation just says that the new money is always equal to your total savings times that interest rate. More savings, more money added. See? It's a simple, powerful loop.
Now, this brings up a really critical difference. In a typical calculus class, you might get a full logbook of your savings, and your job is to figure out the rate of change. But with differential equations, we flip that completely on its head. Here you start with only the rule and your first deposit, and your goal is to predict the entire logbook from scratch. It's a totally different game.
So we have our rule, but a rule isn't a prediction, right? The next step is the crucial one. We have to solve this rule. We need to transform it from a description of change into an actual tool we can use to see the future. This is that process of solving. We're basically on a hunt. We're looking for a specific function, a formula that behaves exactly according to the rule we just laid out. And when we find that function, well, that's when we get our crystal ball.
And here it is. This is the solution. This is the predictive tool we've been working towards. You probably recognize it. It's the famous exponential growth formula. Turns out this function is the only kind of function in the universe whose rate of growth is always proportional to its current size. It perfectly fits our rule.
Let's quickly break down our new tool. P of t, that's what we want to find, the amount of money at some future time t. P naught, that p with the little zero, is just our starting amount. E is Euler's number. It's a special number like pi that just shows up everywhere in nature when you're talking about growth. And k? That's our trusty growth rate, the exact same k from our original rule.
All right, enough theory. We've defined the rule, and now we've forged the tool. It's time to actually put this thing to work and make a real prediction. So let's head back to our piggy bank. Let's say we start with $10. That's our P naught. And the growth rate, k, is 10%, which we write as 0.1. We just plug those two numbers into our tool, and we get this specific formula, tailor-made for our magic piggy bank.
So here's the big question. Using this formula, what are our savings going to be after 10 years? All we have to do is take that t and plug in the number 10.
Let's walk through it together. First, we put 10 in for t. So in the exponent, we've got 0.1 times 10, which is just 1. Easy enough. So now our equation is just 10 times e to the power of 1, and since e is about 2.718, we just multiply that by 10.
And there we go, $27.18. After 10 years, our little $10 deposit has grown to over $27. We just predicted the future using math. How cool is that?
So, we did it. We made a prediction. But let's take one final step back and just appreciate what we've really accomplished here, because it's a pretty big deal.
This right here, this is the journey. This is the fundamental process used all across science and engineering. You observe how something changes, you write down a differential equation to describe it, that's your rule, and then you solve that equation to get a predictive model, and that's your tool.
And that's the final idea I want to leave you with. We used a piggy bank, sure, but this exact same mathematical structure is used to model things like viral outbreaks, colonies of bacteria, or financial investments. Once you can define the rule of change, you suddenly gain the power to predict. So think about it. What else in your world grows according to a simple rule? Thanks for joining us.